In this video, we're going to look at the rotation of axes. We're going to identify non-degenerate conic sections given their general form of an equation. We're going to use the rotation of axes formulas. We're going to write equations of rotated conics in standard form, and we're going to identify conics without rotating the axes. So if we look at the equation y is equal to 2 over x, this is an irrational equation, and we know from our Pre-Calculus 1 class that it looks like this. That it has a horizontal or a vertical asymptote at 0, at x equals 0, and a horizontal asymptote at y is equal to 0. However, if we look at this in terms of a hyperbola, it really is a hyperbola that's been rotated 45 degrees. So here, oh, it's a rational equation. Here, it's actually a hyperbola that's been rotated 45 degrees. So how do we go from a rational function, y is equal to 2 over x, to a hyperbola? We do this with the rotation of axes, and we have formulas that are going to help us through it. So if we have some point xy on the xy axis, normal xy axis, and if we want to find the rectangular coordinates based on x prime, y prime axes, in other words, I'm going to rotate the axes through some angle theta, then we would have this point, which is the point still xy, but on the rotated axes, it is x prime, y prime. So it looks something like this. Well, this is still the angle theta, and then the angle from the point on the rotated axes to that point is phi. That's called phi. Now, if we look at those two triangles that we start out with, that this angle, again, we're going to just move this. So this is the point x prime, y prime. And this is our angle phi, and this is their x prime axes. This is our y prime value. And then we also look at the triangle we start out with, which this is the entire rotation, which is the angle phi plus theta. We have x, y, r in the xy axes. We end up with these two equations. I can replace x with x prime cosine theta minus y prime sine theta, and I can replace my y with x prime sine theta and y prime cosine theta. But if we want x prime and y prime, then we can use these equations into this matrix. Again, this is matrices that we learned in Pre-Calculus 1. And so we end up with this matrix A, which is our coefficient matrix. This is my coefficient matrix. My x prime matrix, this is the x prime, y prime. And then my x matrix, which is x and y. If I invert my A matrix, I multiply it on both sides, I end up with this x prime is equal to. Now this is the equation x prime is equal to x cosine theta plus y sine theta. And then y prime would give me a negative x sine theta plus y cosine theta. So if I have the x's, I can get into the primes. If I have the primes, I can get into the x's. So let's go back to our rational equation. Now, our rational equation, if I multiply both sides by x, I'm going to get xy is equal to 2. My angle is going to be pi over 4. Pi over 4, you're like, what? Well, that comes from the fact that we still have that same XYR stuff. We still have the XYR stuff. And we'll go into this further, so don't panic. You're like, what? We'll go into it further. So then x is going to be x prime cosine pi over 4 minus y prime sine of pi over 4, which the sine of pi over 4 is a square root of 2 over 2. Same with the sine of pi over 4. So I was able to factor out a square root of 2 over 2, x prime, y prime. Doing the same thing with my y replacement with this. So here is my x and its replacement. Here is y and its replacement, and the thing equals 2. So as we continue through, we have this square root of 2 over 2 multiplied by this square root of 2 over 2 gives me 2 over 4. This is the difference of squares, so it's x prime squared minus y prime squared is equal to 2. If I divide everything, well, I'm just going to clean this up, and so I get the 1/2, and then I'm going to divide everything by 2, and I get x prime squared over 4 minus y prime squared over 4, which is equal to 1, which then gives me my hyperbola rotated at 45 degrees. So let's go back up to my picture up here, my graph. So here's my graph. This is my hyperbola rotated 45 degrees. And on the x prime axis, this is my x prime and this is my x prime axis, I went out a distance of 2. On my y prime axis, this is my y prime axis, I went out a distance of 2, and so here is my hyperbola. And along my x prime axis, it's positive, so that's why my parabolics on my hyperbola are hugging my x prime axis. So, here we go. How do we determine what kind of conic we have, and how do we determine our angle of rotation? Well, so we know that x squared can be replaced with all of this, and y squared can get replaced with all of that, and xy can get replaced with all of that. So then I have ax squared, and that gives all of that, becomes this, which basically gives me this. Cosine of 2 theta over sine 2 theta is my a minus c divided by b. A comes from the coefficient on the x squared, c comes from the coefficient on the y squared, and b is the coefficient on the xy term. So then I know that I have the cosine of 2 theta. Now this is the same thing as the cotangent of 2 theta is equal to a minus c over b. In our previous example, I only had the xy term as equal to 2. So in my previous example, my b happened to be 2. My a was 0. My c was 0. And so I had the cotangent of 2 theta is equal to 0 divided by 2, which is the cotangent 2 theta is equal to 0. And I think about, where is cotangent equal to 0? Well, this is the x value over the y value. This happens when the angle 2 theta is equal to pi over 2. So theta ended up becoming that pi over 4. And that's where that came from. XYR stuff is still holding true. It just means that we also have to take into consideration the coefficient on this x squared, the coefficient on the bx, and the coefficient on the c. If I'm asked to determine the angle of rotation, all I'm going to pay attention to is the coefficient on my x squared, which is a, and that's 1, my coefficient on the xy term, that's 2, and my coefficient on the y squared, that's 1. So I know that the cotangent of 2 times my angle is going to be my 1 minus 1 over 2. Well, this also gives me 0 over 2. And we know from my previous example up here, when I get the cotangent is equal to 0, that means 2 theta has to be pi over 2. That means my theta, my angle of rotation, is pi over 4. Let's do another example. So here my a is 7, my b is 4 the square root of 3, and my c is 3. So the cotangent of 2 theta is going to be the 7 minus, I'm going to make sure I've got this right, a minus 3, 7 minus 3 over 4 the square root of 3. So this gives me 4 over 4 the square root of 3, which is 1 over the square root of 3. Now I look on my unit circle and I look for the ratio in which the x value over the y value on my unit circle gives me the 1 over the square root of 3. That happens when 2 theta, or my angle, is equal to pi over 3. And so my angle of rotation is pi over 6. Pi over 6 is my angle of rotation. Let's take a look at my last one here. And so I have a is 1. B is negative 2, the square root of 3, and C is negative 1. So we have the cotangent of 2 theta is equal to, well, this is 1 minus a negative 1 over negative 2, the square root of 3. So I end up with a negative becomes a positive 2, and then I have negative 2, the square root of 3. And so I get 1 over negative square root of 3. Now, this angle, this is a negative there, We know that cotangent, its inverse is in quadrant 1 and 2. So I look in quadrant 2, in which I have the angle of rotation. I'm looking in quadrant 2, in which my cotangent is a negative 1 over the square root of 3. Well, this happens when my angle, which happens to be 2 theta, is equal to 2 pi over 3. And so my angle of rotation then, theta, is pi over 3. So those are my angles of rotation. Now, if I'm trying to determine by inspection, and by the way, these equations here, these equations right here, and this information right here is going to hold true whether or not A is 0, B is 0, or C is 0. Any of these are going to hold true. So if any part of these are hold true, then we still do what we call the discriminant, and we look at the coefficient on the B, which is the xy term, and minus 4ac. So even if there's a B term is 0, this is still going to hold true. I promise you this. So if I'm asked to determine the type of conic, again, I'm going to say A is 1, B is 2, C is 1. So using the discriminant, which is B squared, so 2 squared minus 4, A is 1, C is 1. So I end up with 4 minus 4, which gives me 0. If this thing equals 0, my conic is a parabola. So I'm expecting when I do the rotation of axis that I have a parabola. Looking at my next example here, I have, and if you haven't been paying attention, now is the time to pay attention. We keep using the exact same conics again. Notice that this A is this A up here, it's pi over 4. This B is this B up here, and this C is this C up here. So that we already know the rotation of axes. We already know what we expect to find. And then in a moment, we're going to do the whole process of doing the rotation of axes. And we also know what we expect to see when we get done with the rotation of axes. So I just wanted to note that. A is 7, B is negative 4, the square root of 3, C is 3. So B squared is negative 4, the square root of 3, the quantity squared, minus 4 times 7 multiplied by 3. So I have 4 squared, which is 16, and then the square root of 3 squared, which is, let me just want to get my calculator out. That's going to be a 3, of course. So I was doing 16 times 3 in my head, and it wasn't working out, so I had to get my calculator. So this is going to be 48 minus 4 multiplied by 21. That's the 7 times 3. So 48 minus 84. This clearly is less than 0. So if this is less than 0, I'm expecting an ellipse on my rotated axes. Okay? Now, on my last example, which we know is C from above, my A is 1, my B is negative 2, the square root of 3, and my C is negative 1. So I have my B squared, which is negative 2, the square root of 3, the quantity squared, minus 4 multiplied by 1 multiplied by negative 1. And I don't have to do any work here. Without doing any work, I know that my first term, which is B squared, will be positive. And I also can see that this negative and this negative will make that positive. So I know that my answer will be positive, but I'm going to go ahead and go through this. So I have 4 multiplied by 3, which is 12, plus 4, which is greater than 0. And by this, we know this is a hyperbola. All right. Now, get yourselves comfortable. I'm only going to do one of these because they are long. They are super, super, super long. So I'm only going to do one of these, and I'm not going to do all of them. So I'm going to start out with the fact that I have these replacements. I know that x will get replaced with x prime, the cosine of the angle of rotation, minus y prime, the sine of the angle of rotation. So let's go ahead and just do that now. X is equal to x prime. And I believe that this angle of rotation was pi over 4. So I'm just going to come back up here to confirm this is pi over 4. And it was. So that's A right there. Notice it's the exact same thing down here. So this is going to be the cosine of pi over 4 minus y prime, the sine of pi over 4. So my x replacements are going to be the square root of 2 over 2 x prime, and then minus, this will end up being y prime multiplied by the square root of 2 over 2, so I just factored that out. So everywhere I see x, I'm going to replace it with that. My y replacement is going to be x prime, the sine of my angle, plus y prime, the cosine of my angle. So my y replacement in my rotated axes is going to be x prime, the sine of pi over 4, plus y prime, the cosine of pi over 4. So we get y is equal to, again, I'm going to get the square root of 2 over 2, x prime plus y prime. All right, now I have a replacement for this x and this y. I also have a replacement for the x squared and the y squared. All I have to do is square these. And then I have to do the multiplication of the two. So what I'm going to do is I'm going to do each and every piece individually. So I'm going to start out with the x squared term. So I'm going to come over here and I'm going to call this my x squared term. This is going to be the square root of 2 over 2, x prime minus y prime, the quantity squared. So that is my x value squared. Now when I square the square root, this is going to give me 2. When I square the 2, it's going to give me 4. Inside, the x prime, y prime gets squared, and it is a perfect square trinomial. So it'll be x prime squared minus 2x prime y prime plus y prime squared. So we know that my x squared replacement will be 1/2 x prime squared minus x prime y prime plus 1/2 y prime squared. That is my first replacement. My second replacement is going to be 2xy. So I need 2xy. This is going to be equal to 2. My x value was the square root of 2 over 2, x prime minus y prime. My y prime was the square root of 2 over 2, x prime plus y prime. So this becomes 2 multiplied by the square root of 2 multiplied by the square root of 2 is 2. And then, of course, we have 4 because it's 2 multiplied by 2, so that's 4. That's the coefficient. Now, this is the difference of squares, so it'll be x prime squared minus y prime squared. And you can see that 2 times 2 is 4, which reduces to the 4. So this replacement is x prime squared minus y prime squared. All right. Now I have to replace this y prime, or this y squared. So now let's go ahead and do it, and it's a plus there. Just make sure I got a plus. So this is my third replacement. Y squared is going to be equal to the square root of 2 over 2, x prime plus y prime, the quantity squared. Once again, this is a perfect square trinomial, and I'm going to square the square root of 2 and the 4, so I get 2 over 4. X prime squared plus 2x prime y prime plus y prime squared. Distributing that 1/2, it's 1/2, so I have 1/2 x prime squared plus x prime y prime plus 1/2 x y prime squared. All right, so let's write down what we have so far. So we had the x squared term. That x squared term gets replaced with 1/2 x prime squared minus x prime y prime plus 1/2 y prime squared. And then I had a plus 2xy, so this is a plus 2xy. So that 2xy gets replaced with plus x prime squared minus y prime squared. And then I had plus the y squared. That y squared gets replaced with 1/2 x prime squared plus x prime y prime plus 1/2 y prime squared. Now that's not everything. That's just to that point. I also have in this equation is I also have a x So I have plus, now if you remember, my x was, here my x was the square root of 2 over 2 x prime y prime. So plus my square root of 2, that was already there because it is, excuse me, it should be a minus. That should be a minus x squared. This term is a minus the square root of 2x. So it'll be minus the square root of 2. My x replacement was a square root of 2 over 2. My x prime minus my y prime. This is long, so I'm only doing one. And then I have plus y, the square root of 2. So then I have plus the square root of 2y. That replacement is going to be plus the square root of 2. My y was the square root of 2 over 2 multiplied by x prime minus plus y prime. And this thing equals 0, I believe. Let me go back. Yep, and it equals 0. Okay, now, all of this glory is the rotated axes equation. This is what the equation looks like when we rotate the axes. And it's terrible looking. But we're going to start cleaning stuff up. Now, let's starting with the x squared terms. This is an x squared. This is an x squared. Those two get added together. Oh, wait, here's another x prime squared. Those all get added up. So when I add up all of those x prime squareds, I'm going to get 1/2 plus 1/2, which is 1 plus 1 more, which is going to give me the 2x prime squared. Now, this x squared, this x prime y prime, and this x prime y prime, it's a mouthful, those cancel out. So like I said, this is starting to look a lot better. When I add up the 1/2 y prime squared and this 1/2 y prime squared, I get 1, but then I have a minus one of those. So those cancel out. So you'll notice that we started out with something terribly ugly, but it's actually starting to look not too bad. Now, we're going to go ahead and do this distribution, and so we have minus. We have the square root of 2 times the square root of 2, which is 2 over 2, so it's going to be 1. X prime minus y prime. And then plus, and this other one, we get the square root of 2 over 2. So we end up again with 1. X prime plus y prime is equal to 0. So we started out with something terribly ugly, and now it's not actually looking too bad. So let's continue. So we have 2x prime squared minus x prime plus y prime plus x prime plus y prime is equal to 0. Oh, look at this. Those x primes cancel out too. Well, that's really nice. So I get 2x prime squared plus y prime plus 2y prime is equal to 0. Now, this is a parabola, so I'm going to make it match the way I would expect a parabola to do. So I'm going to bring the 2y to the other side, and then I'm also going to divide by 2. So I have x prime squared is equal to a negative y prime. And so, let's talk about what this graph looks like. So I have this is my regular xy. Here's my regular y, here's my regular x. I am going to rotate my axes for the primes 45 degrees. This is getting rotated 45 degrees, or pi over 4. This becomes x prime, this becomes y prime. If I were asked to graph this conic, I know that this conic, regular x squared is equal to y squared, or x squared is equal to negative y. That tells me that I'm opening downward. So I would open downward, and it's going to look something like that. So that's what my graph would look like. If I am required to figure out any of these points, the vertices, the foci, all of that stuff, right? Because that could come up. Now, remember that the coefficient in front of the non-squared term is equal to 4p. So 4p is equal to negative 1. P is equal to negative 1/4. Now, this is negative 1/4. on my prime. So my focus will be along the prime axis. This would be the point 0, negative 1/4. And then, of course, I would have my directrix, which would be along the prime, would be the y prime is equal to 1/4. So that is on the primes. Now you're thinking, okay, cool. How do I write the 0, negative 1/4? It's in the primes. What if I'm asked to write that focus in the regular xy plane? Well, we have an equation for that. If you remember from up above, remember when I took that time to talk about those other equations that we get, these here? That's what we do here. So we can get from our primes back into the x, it's not that one, sorry, it is these here. So these are the ones that I can do to get back into my regular x and y answers. My x prime, remember my x prime, my x prime was 0, my y prime was 1/4, my theta is still pi over 4, and it was a negative 1/4. So the x would be equal to my x prime, which is 0, the cosine of pi over 4, minus my y prime, which was a negative 1/4, the sine of pi over 4. So this is going to be x is equal to, well, 0 times cosine is 0, and this is going to be a positive 1/4, and then the sine of pi over 4 is a square root of 2 over 2. So the x coordinate, now this is my x prime, y prime, so my x coordinate in the regular xy plane is going to be the square root of 2 over 8. Similarly, my y in the regular xy plane is going to be my x prime, which is 0, multiplied by the sine of pi over 4, and then plus my y prime, which was a negative 1/4, the cosine of pi over 4. And so this gives me a y value of negative 1/4 multiplied by the square root of 2 over 2. So this gives me the negative square root of 2 over 8. So that foci in the regular xy plane relates to the point square root of 2 over 8, comma, negative square root of 2 over 8. And that's it for this video. I leave it up to you to follow through. Holy smokes, are these long. One of these takes a long time to go through. Notice all the steps that I had to go through to just do one of them. I'll leave these other two for you to do. And that's it for this video, and we'll see you in class.